Okay. So we are trying to assess normality here for the distances to determine how well that distribution would be would fit a normal distribution. Okay. So what we're going to do to get started, I'm going to do it all here in the setup method. I'm going to do float mean distance. I'm going to call get average distances. I'm going to do float SD distance to be get SD distances. Okay. And so let's go ahead and think about it. So if I did float 1 SD below, that would be the mean distance minus the standard deviation distance. If I did float 1 SD above, that would be mean distance plus standard deviation of the distance. So that is taking the mean, subtracting a standard deviation, adding a standard deviation. Okay? What I'm going to do is copy this. Alright, and I'm doing 2 standard deviations below, 2 standard deviations above, and here I'm multiplying the standard deviation by 2. And remember, if that distance was about 24 feet, let's just say. So now you're adding and subtracting like 48 feet from the mean. So like 396 minus about 48, and then 396 plus 48. That's 2 standard deviations above the mean. Okay, and then 3, which really should be like basically all of it, right? Is 3 below, 3 above. So those are my markers for, if you think about this graph, I'm kind of like finding these. I'm taking the mean, subtracting a standard deviation, adding a standard deviation. That's this marker. That's this marker. So what I'm going to do is loop through all the data set and figure out, okay, if you're within that range, I'm going to add 1 to my counter. Okay, I'm going to create some counters. Same thing for the next standard deviation. All right. So my counters, which these really could be ints because they're going to be whole numbers. But I'm gonna make them floats, and the reason I'm going to make them floats is I don't want integer division to happen. I want like an average or a proportion. So I'll show that whenever we do it. So let me do some first standard deviation, float some second standard deviation, and float some third standard deviation. Okay. Now one thing I'm going to do, just to show you, distances dot length. All right. There were 4,661 home runs. So we're looking at a big data set. Okay, we got it loaded by the string that's in that text file. We're looking at a big data set. Okay. So what we're going to do is pass through all of the distances. So as long as I is less than distances dot length. Okay, I'm going to say if distances of I is greater than or equal to 1 SD below, and distances of I is less than or equal to 1 SD above, then what I'm going to do is I'm going to add 1 to some first SD. Okay, so this is going through all the values, and if the value is between both of those, between the lower, bigger than the lower bound, lower than the upper bound, or less than or equal to the upper bound, then add 1. All right, and then I can do this all right, so now it's 2 standard deviations below and 2 standard deviations above, and this is I'm adding second, 3 standard deviations below, 3 standard deviations above, some third standard deviation. Now these are floats, but you can add 1 to a float. Even though they have decimal points of 0.0, they're just going to get that 0.0 every time. Okay, so then I'm going to print out. Okay, so let's see, what would it be? Let me do them as proportions first. So proportion would be sum first SD divided by distances dot length. So distances dot length is how many home runs were hit. Sum first SD is the number of home runs that were hit that are within 1 standard deviation on each side of the mean. Okay, I'll print that. That will give us a proportion. Now, percentages basically are used interchangeably. But if you wanted to multiply it by 100 and put a percent sign on it, that proportion would become a percentage. But let's see this first. I have not done it yet. Oh, that looks pretty good. 67% is within 1 standard deviation, 95% within 2, and look at that, 99.7% within 3 standard deviations. Okay, so very close to a normal distribution. In fact, if we could graph this, we might do this in one of the later projects, we can see that this is going to appear approximately normal. Okay, and then one more thing, if I had done an int here for some first SD, if I do an int divided by an int, then it kind of chops off that decimal place, right? So I don't want to do that. This is giving me a float divided by an int is still a float. Now, if I wanted to multiply this by 100, and then let's say add a percentage sign on it, then I can get, that 0.6717 becomes 67.17%.